Hello, this video is for learning intention 30. And now that we know what a discrete probability distribution is, we need to know how to calculate the mean, median, and mode. So I'm going to break this up into two parts. Part 1 is going to be examples and how to calculate the mean, and part 2 is going to be median and mode. Now, I want to make it clear that this maths that only involves addition and multiplication of fractions, this maths is what makes casinos successful. This is why casinos rake in billions of dollars every year, because they understand how discrete probability distributions work and the general population do not. And it's hard. There are a lot of counterintuitive things here to watch out for. So I think the best thing I can do is start with an example about a game with some money. So let's invent a game. So to play this game, it costs $1. So you rock up to the casino, wherever, it costs $1 to play this game. Alright, and it's a spinner game. And I'm going to do two separate ones. So here we have the first, oh hang on, I've got a circle. I'm going to draw a circle properly. Bear with me. Here we have the first spinner. So we're all familiar with spinners. And here we have the next spinner. Alright. It's broken up into 4 equal pieces. And it costs $1 to spin one of the spinners. And of course, we're going to have our little arrow here. Costs $1 to play either of these games. On this spinner, if you land here, costs you $1 to play, but you get your dollar back. If you land here, you get nothing, $0. So you lose the $1 that it costs to play. You land here, you get $2 back. Hey, that's nice. If you land here, you get 50 cents back. Alright, let's look at this one. If you land here, you get 50 cents back. If you land here, you get nothing back. If you land here, you get $5 back. That's quite nice. And if you land here, you get 50 cents back. Which one should you play? There must be some maths here. I mean, you look at this one and you think, oh, this one's got the $5. That's a bit bigger. But then you look at these and you got $0, 50 cents, 50 cents. If you land on any of these, you're guaranteed to lose money. Whereas if you land on this one, you get the $1 back that it costs to play. So how can we calculate which one's better? Well, these are discrete probability distributions. Here's how you calculate it. I'm going to write the formula, and it may look intimidating at first. Trust me, it's not. The expectation of a random variable, or the mean, or the average value, what you expect the random variable to do, is equal to the sum of x times the probability that the random variable gets assigned that value for all x. Boy, doesn't that look scary. Look at all those symbols. It's actually not scary at all, and I'll show you why. So let's do the discrete probability distribution for this example. Let's roll this up. Whoops, I went black. Let's have a look. So I'm going to be really formal here, because I don't want you to lose marks for not defining things properly. We have to define what the random variable is. So the first thing you should always do is define the random variable. So let x be the winnings from one spin. So you pay your dollar, you do one spin, X is going to be the winnings. How much you get? So we have X and a probability that X equals X. All right. If it lands there, you lose $1 because it costs you that dollar to play. You get 0 back, you lose $1. If you land there, you get your dollar back. If you land there, you win $1. If you land there, you lose 50 cents. All right, and the probability of landing on any of those is 1/4. This formula lets you work out the average of this game. In other words, it lets you work out what you expect the random variable to do. So the average is kind of like what the random variable is most likely to do. Let's use this formula. This is how you use this formula. To calculate the expectation of X, you go that times that, plus that times that, plus that times that, plus that times that. That's what this formula means. Look, it means X times the probability that X equals X, plus, because it's a summation, X times the probability that X equals X, plus that. So let's do that. So we've got -1 times 1/4, plus 0 times 1/4, plus 1 times 1/4, plus -1/2 times 1/4. What does that equal? -1/4. Well, that's going to be 0 plus 1/4 minus 1/8. And that equals -1/8, which in decimal, let's do it as decimal dollars, that's minus 0.125. What does that mean? This means, on average, you stand to lose 12.5 cents every time you play this game. Doesn't mean that you'll ever actually lose 12.5 cents on any given spin, you can't. But on average, over time, the more you play, the more it'll converge to this value. The average loss for this game is 12.5 cents. You play, basically, the more you play this game, the more you lose. It's a losing game because the expectation is negative. The expectation is that you lose money. Let's have a look at this one. So we're still going to have X be the winnings from one spin. Let's draw up our table, our probability distribution. Alright, what's the expectation of this game? Well, we have X, probability that X equals X. Here you'd lose your dollar, here you'd lose 50 cents, here you'd lose 50 cents, here you'd win $4. Hey, that's nice. And each one has a probability of 1/4. Let's calculate the expectation of X. So that's -1 times 1/4, which is -1/4, minus 1/8, minus 1/8, plus 1. So -2/8 minus, well, 2/8 is -4/8 plus 1 equals 1/2, or 50 cents. What does that mean? It's a positive value. This means the expectation of this game is 50 cents. The average value of this random variable is 50 cents. On average, every time you play this game, you'll win 50 cents. Alright, here's the kicker, here's the thing. You're told that gambling is bad. Well, if you managed to find a game at the casino that paid on average 50 cents every time you played, you would play that game as much as possible because it's a winning game. It pays out. On average, it pays 50 cents. The more you play, the more you win. However, every single game at the casino has an expectation that's negative. Every game favors the house. Doesn't matter what game it is. They have different odds, but they all pay back to the house on average. It might be a minuscule amount, might be 12.5 cents. But if lots and lots of people play that game, then that's a lot of money. So the reason gambling's bad is because all the games that you'll ever play at a casino have negative expectation. Now, if you go to the casino, you know, they'll have bright lights. They'll say, try your luck. It's very colorful. It's very pretty, you know. They make it look very attractive to disguise from the maths. This is what's actually happening. You are losing. If you want to know the exact amount you're losing, Google it. I would recommend looking up roulette as an extra activity. See if you can draw your own probability distribution function. Probability distribution for roulette and prove that it's a losing game. All casinos are like this. You'll never find a game that pays out winning. But that's how you calculate the expectation of a random variable. So the average value it spits out. All right. I'll split this into 3 parts. In the next video, I'll show you some of the properties of a random variable and calculating its expectation. And if you have been, thanks for watching.